In these questions, we're going to look at the optimal time for observing a star, given the rising and setting information. So in question 1, we know that at a given location, a star will rise at 23:10 GMT. It will then move through the sky and it will set the following morning at 5:20 in the morning. Now the optimum time at which to observe a star is at its highest point, which it culminates, which you can see here would be exactly halfway between these two times. So ultimately this question is asking us to find the midpoint between 23:10 and 5:20 in the morning. So quickly between them, so between 11:10 at night and 5:20 in the morning, there are 6 hours and 10 minutes. We want to find the halfway point, so we only want half of that. So that will be 3 hours and 5 minutes of time. So if we're looking for that, we're going to add on 3 hours and 5 minutes onto 11:10, or if you felt it easier, you could also subtract it from 5:20. So 3 hours added onto 11:10 would be 10 past 12, 10 past 1, 10 past 2, and then on the 5 minutes will be 2:15 in the morning. So the optimum time to observe this star would be at 2:15. Hopefully we're in the swing of things now, so it's a very similar question. So again, we've got a star rising this time at 26 minutes past 9 in the evening, and it's setting at 4:42 in the morning. So again, we want to work out the time in between here, so it's 6 hours and 16 minutes between them. If it helps, sometimes it might help to convert this into minutes. That'll help with the maths later on. So 6 hours, 6 lots of 60 is 360, plus 16 minutes gives us 376. Obviously we want the midpoint, so we're going to divide that by 2, and if we divide that by 2, we're going to get 188 minutes. And then we need to convert that back into hours. So I know that 3 lots of 60 is 180, so therefore there's 3 hours, and then there's 8 minutes left over. So 3 hours, 8 minutes would be the middle point. So I'm going to add that on to 9:26. So that would be 10:26, 11:26, 12:26, and then adding on the 8 minutes gives us 34 minutes past 12. From a given location, a star rises at 22:52. So we know our star rises at 22:52. And we know that this time it culminates at 18 minutes past 1 in the morning. And it's asking us at which time will the star set. So we know that the time it takes to go from here to here will be twice the time it takes to go from rising to culmination. So number 1, if we can work out the time between 10:52 and 1:18 in the morning. So again, if I was doing this, I'd go 10:52 to 11:52 to 12:52. So therefore that means there are 2 hours. And then from 52 round to 18 minutes. So 52 would be 8 minutes to the hour, plus 18 minutes would be 2 hours and 26 minutes. And then we know that therefore the time it takes to go from culmination to setting will be the same again, because it's only halfway, 2 hours and 26 minutes. So if I add on 2 hours and 26 minutes onto my 1 hour 18, I'll find the time. So 1 hour, so 1 o'clock in the morning, add on 2 hours is going to make it 3 o'clock in the morning. 18 minutes plus the 26 minutes is going to be 3:44. So the answer will be 44 minutes past 3 in the morning. Okay, next one. A star culminates on the observer's local meridian at 7:15 in the evening. So therefore we've got one observer observing the star culminating at its highest point at 7:15. Whereas the same star culminates on a second observer's local meridian. So I'll take my second observer's local meridian at 19:35. Can I calculate the longitude difference between the two observers? Well, we can look at the time difference between when that star culminated for those differences, and we can see that there are 20 minutes between 1915 and 1935. Now we know that 1 degree is equivalent to around about 4 minutes. So therefore, if we're looking at 20 minutes, we know that that is the equivalent of, what do we need to go from 4 to 20 minutes times by 5. So we do the same on this side, gives us 5 degrees. So we know that the longitude difference between those two observers is 5 degrees. Elise and Rodney are 2 astronomy students observing the culmination of Mars from 2 different locations in the UK. At the moment of Mars's culmination, Elise sends a text to Rodney, and exactly 2 minutes later, Rodney sent a text to Elise to say that he has just observed the culmination of Mars. Which student is further east? Okay, so the student that is further east will be the one that has seen it first, because the stars move from east to west. So Elise will be the student. And what is the difference in longitude? Okay, so the time is 2 minutes, and we know from earlier that 4 minutes is equivalent to 1 degree. So what do we need to do to go from 4 to 2 minutes? Well, we divide by 2. So if we do the same over this side, 1 divided by 2 gives us 0.5. So we know that the difference in longitude between them is ½ degree. Okay, and finally, Gemma is observing from Greenwich Park in London, which is on the prime meridian, so therefore has a longitude of 0 degrees. And she observes that the Orion Nebula is due south at 16 minutes past 10 in the evening. So Gemma's friend is observing from Penzance in Cornwall, which has a longitude of 5.5 degrees west. At what time will Otis observe the Orion Nebula when it's due south? So again, we can use our same conversions that we were using. So we said that 1 degree was equivalent to 4 minutes, and we know that Otis is 5.5 degrees different. So how do we get from 1 to 5.5? Well, we times obviously by 5.5. So we're going to do the same on this side, which will give us 22 minutes. So therefore we know that there will be 22 minutes gap in time, and then because Otis is west, Otis will see it later. So therefore we want to take 22:16 and we want to add on the 22 minutes. And so if we do that, Otis will see the nebula culminating at 22:38 GMT. So again, hopefully you've worked out how to do them, and you've got a bit better at doing these questions, and you've done well on the Kahoot. So well done. Thank you.